All right, so next up we are looking at our kind of type 2, not quite as simple rational functions that we're going to be graphing. Okay, so here's our general form. Okay, and we're going to be going through two different methods that you can use to graph these. So method 1 is on this page, and then second page, method 2. Okay, personally, I prefer method 2, but it is totally a preference thing. Whichever one you like better is totally fine. So you're just going to want to pick one of these two methods and be really good with it so that you are solid in what you need to work with, okay? All right, so let's start by taking a look at method 1. So method 1 is basically, you're going to start by using these two formulas right here, okay? So to find your vertical asymptote is just x equals negative d over c, or set the denominator equal to 0 and solve. Okay, why? Well, because asymptotes show up when you have 0 in the denominator, right? That's what the problem is. You can't divide by 0. Okay, so we're looking for what value is going to make the denominator equal 0. So that's what we'd start with. Okay, so let's jump down here and do that example. So for this particular one, our denominator is x plus 3. So if I set that equal to 0 and solve, x equals negative 3, right? That is my vertical asymptote. So vertical asymptote, there it is. All right, and then the horizontal asymptote, to find the horizontal asymptote, it's a over c, which is the ratio of these two coefficients, okay? So why is that? We're gonna come back to that in a minute, okay? When we look at method 2, that's actually gonna show you why it works to figure out, using that to figure out what this horizontal asymptote is. Because your horizontal asymptote, remember when we did the level 1 ones, right? Your horizontal asymptote was tied to your vertical shift. So we're going to talk about how those two coefficients tie to your vertical shift when we look at method 2. But for right now, it would just be that your equation would be y equals, and it's the ratio of these two coefficients. So in this case, negative 4 over 1, right? There's an invisible 1 there. So just y equals negative 4. Okay, so that is our asymptotes using those two formulas. Okay, and next what we're going to do is we're going to find either the x or the y-intercept. You don't need both. Depending on the equation, one will be easier than the other, but it doesn't matter which one you go with. Okay, so let's take a look at this. To find your y-intercept, you would set x equal to 0 and solve. So I would get y equals negative 4 times 0 minus 6 over 0 plus 3. So that would be negative 6 over 3 or negative 2. Okay, so that is the point 0, negative 2. That's my y-intercept. Okay, lovely. If we had gone with the other one, so if I wanted my x-intercept, I'd set y equal to 0 and solve. So it would be 0 equals negative 4x minus 6 over x plus 3. Okay, the first thing I would do to solve this is I would multiply both sides by x plus 3. Right? So this would cancel, and that leaves me with just 0 equals negative 4x minus 6. And then you know how to solve that. Add 6, divide by 4, and we're going to end up with x equals negative 3 halves. So it'll be the point negative 3 halves, 0. So really, like, solving them is not more difficult for one or the other. They're pretty easy solves. This is going to be a little bit of a nicer point because it's whole numbers than that one. But that won't always be the case. It might be that sometimes the x-intercept's nicer. Okay, great. So now what are we going to do? Now we go to our graph. Okay, so I'm going to go to my graph, and I'm going to start by putting in my two asymptotes. So my asymptotes were x equals negative 3 and y equals negative 4. So here's x equals negative 3 and y equals negative 4. Okay, and then what I'm going to do is I'm going to graph these two intercepts. So 0, negative 1, and here's the tricky part, okay, because you might be tempted to say, oh, start from here and go 0, negative 2 over to here. No, okay, because this, we're not going off of a modified table of values. We went off the legit equation. So you need to plot this in the regular spot. 0, negative 2 would be there. Okay. And then negative 3/2 0. So that's negative 1.5 0. Oh man, I did it wrong. Oh my goodness. I don't know what's wrong with my brain. 0, negative 2 is down there. Negative 3/2 0 would be there. My bad. Okay. Okay, so once we have those points, now what we're going to do is we're going to kind of go backwards to figure out our product. Okay, so remember how here we would look at these and we would say, well, since my product is 6, I would go over 2 and up 3 because 2 times 3 is 6, right? Or over 1 and up 6 because 1 times 6 is 6, right? Well, we're going to use this point that we have here to construct this. Okay, so this is where this point is a little bit easier to deal with. Okay, so from my modified origin to this point, I have to go over 3 and up 2, right? So looking from my modified origin over to here, right, it was over 3 and up 2. So my product is going to have to be 3 times 2 or 6. Okay, or alternatively, going to this point, I could have said, well, to go from here to there, I would go over 3/2 and up 1, 2, 3, 4. Or I'm sorry, over 1.5, right? And up 4. So 1.5 times 4, which is also 6. Okay, so either way, we get the same product. And then once you have that, now we have enough information to graph the rest of this. So now I know my product, so I can say, okay, well, over 1 and up 6, right? Over 2 and up 3, over 3 and up 2, already there, right? And then over 6 and up 1, there's this part. And then similarly over here, over 6, down 1, over 3, down 2, over 2, down 3, and then over 1, down 6. And there's my graph. Okay, so there's kind of a lot with this method, right? You figure out what your asymptotes are. You figure out either your X or Y intercept, it doesn't matter which. Okay, graph all that stuff. And then you can use that to figure out your product. Okay, so this is a totally legit method. And if this method makes sense to you and you like having this kind of like list of steps to follow, that is totally cool. You are welcome to do that. Okay, personally, I prefer method 2. Okay, so here's what method 2 is. We're going to graph the exact same function, right? So same function that we did here. Okay, so we're going to graph the same function, but here's what we're going to do is we are going to use long division to rewrite this problem. Okay, and that will basically turn it into a problem like the ones we did yesterday. Okay, so this only works, and I should say this, both of these two methods, right? The difference between the problems from yesterday to the problems today is the ones that we did yesterday, there was one variable just in the denominator. It was just an x to the first power in the denominator. Now we're looking at x to the first in both the numerator and the denominator. Okay, so that has to be true for this method to work. Okay, so we're gonna set this up with long division. So I'm dividing negative 4x minus 6 by x plus 3. Okay, so what do I have to multiply x by to get negative 4x? Well, negative 4. Distributive property, negative 4x minus 12. When I subtract these cancel, negative 6 minus negative 12. So negative 6 plus 12 is 6. So really easy long division, and they all end up being that way. Right? And when you go to write your answer, it's the thing you got at the top plus your remainder divided by the thing you were dividing by, right? And then from there, now this is just like the ones that we did in our last class, right? I've got my product number up here. This is a shift left 3, and this is a shift down 4. So when I go to graph this, here's my left 3. Here's my down 4. And then I have a product of 6. So 1, 2, 3, 4, 5, 6. Right? Over 2, up 3. Over 3, up 2. And we are golden. And there we go. Okay. So personally, I like this method a lot better. This is kind of the method that works better for me. Okay. All right, now really quick tangent. Remember how I said in method 1, you find the ratio of those coefficients to figure out your horizontal asymptote? Right, well, your horizontal asymptote is connected to this shift right here, right? So it's connected to this number up here. That's where this idea of the ratio of the two coefficients comes into play, because you're looking at, well, what do I have to multiply this by to get to this? Okay, so you're comparing those two numbers to figure out what goes up top, and that's why that gets you your horizontal asymptote. All right, great. So let's take a look at a couple of examples down here. Okay, so we're going to do both methods. So this guy, I'm going to start by doing the long division method. Okay, so I'd have 2x minus 2, and I'm dividing it by x minus 3. I have to multiply x by 2 to get 2x. So that's 2x minus 6. Subtract those cancel. Negative 2 minus negative 6 is 4. So it would be 2 plus a remainder of 4 over the thing we divided by. So I'm shifting up 2. I'm shifting to the right 3. And then my product is 4. So 1 times 4 is 4. 2 times 2 is 4. 4 times 1 is 4. Right? Negative 1 times negative 4, negative 2 times negative 2, and negative 4 times negative 1. And there's my graph. Okay, so personally, that is my preferred method. That's the one that I like. Okay, but let's do this one using that first method just to kind of compare. So the vertical asymptote you get by setting the denominator equal to 0, right? So I set this guy equal to 0. So 2x minus 4 equals 0. That's a quick solve. Add to both sides, divide by 2, and we're going to get x equals 2 for our asymptote. The horizontal asymptote, that's the ratio of your coefficients. So it's going to be 5 over 2. Okay, and then I want to find one of my two intercepts. So I'm going to say, let's set x equal to 0. So then y would be 5 times 0 over 2 times 0 minus 4. And that's just going to simplify to 0, right? So I have the point 0, 0. Okay, so asymptotes. X equals 2. Here's all the points with an x coordinate of 2. Y equals 5 halves, that's 2.5, right? So 2.5 would be there. Okay, 0, 0. Remember, you just plot that regular. It's not a modified one. It's a regular one. Okay, so then my product, right? To figure out what my product is, right, I have to go from here. I'm going over 2 and then down 2.5, right? So it would be 2 times 2.5. Okay, double check your signs, right? It's a negative and a negative, technically. So that would be 5. So a product of 5. Okay, and that gives me the info I need. So I'm going to go over 5. 1, 2, 3, 4, 5, and down 1, because 5 times 1, right? Over 1, down 5. It's going to end up kind of between some blocks. Gives me some points to go off of. 1, 5, 5, and then 5, 1. And there we go. Okay, so that is method 1. So I know method 1 kind of takes a lot longer to kind of explain through, but it's really not that slow if you're doing it out. Okay, so this guy, I'm going to go ahead and do a long division again. So 2x minus 3 divided by x plus 1. So I have to multiply that by 2. So 2x plus 2. Subtract negative 3 minus 2 would be negative 5. So it's 2 plus negative 5 over x plus 1. So I'm shifting up 2. Shifting to the left 1. And similar to the last one, my product is 5. Okay, so in this case, we're only going to have 2 points, and that's fine. Plot whatever the easy points are, and then just sort of eyeball it from there. And there we go. All right, and then we just have kind of a note down here that I wanted to address. So I mentioned before, right, part of our definition of a rational function is that you have to have two polynomials with no common factors, okay? So I want to take a look at what happens if you did have a common factor, okay? So say we had this function right here, okay? So 3x minus 3 over x minus 1. I have a common factor of 3 on the top, and then we see that these common factors would cancel, and that would simplify to just 3. Okay, so what ends up happening here is that now our equation is just f of x equals 3. Okay, well, that's just a line, right? That's just the line y equals 3. It's just a horizontal line. So what kind of happens, though, is because we had this common term cancel out, the original function, there was a problem at 1, right? I can't plug 1 into this function. If I do, I get something wrong, right? I can't divide by 0. But the end result doesn't have a problem here. So what you would have to do is you would have to simplify it and then specify x can't be 1 because it was a problem here. And what's going to happen in your graph is you're not going to have an asymptote, right? Because this graph, right, y equals 3, this is just a straight up horizontal line, right? So it's just a horizontal line. But what's going to happen is at the number 1, just at the number 1, there's no value there. So what we say is we call that a hole. It's not an asymptote because where these guys are approaching, say, -1 in this case, but never reaching it, they're kind of approaching it in different directions. This way it's getting smaller, this way it's getting bigger. So it's not an asymptote like that. What it is just a hole. It's one number that just gets jumped over. Okay, so anytime you have a common factor that cancels, it creates a hole in your graph where your graph is continuous, it keeps going, but there's that one spot that it jumps over. Okay, so there's no asymptote, just a hole if there's a common factor, and you would have to just simplify it and then specify whatever the original restriction was.